In this video, we're going to solve trigonometric equations where each equation contains one or more trig functions to where the argument is not just a simple x. Like here, it's not cosine of x, but it's cosine of 2x. Okay, now before we get started, I want to point out that all of the trig equations that we've solved so far and that we're going to solve in this video, you can interpret the trig functions as being in radians or degrees or whatever unit you want. We've been solving them in degrees, but it doesn't matter. This isn't like a case where, like in calculus, when you think about taking derivatives of trig functions, it's different depending if you're in degrees or radians. It doesn't matter, because you can think about, cosine of 2x. Once you choose an x, this is just a number. And so, like, as long as you have to be consistent across the entire equation, you can't like have some trig functions be in degrees and some be in radians. But as long as you're consistent saying all of these trig functions are in degrees or all of these trig functions are in radians, well, you can think about it. Let's say that x is 30 degrees, and that solves the equation. Okay, well, if you convert that angle to radians and you take the cosine of 2 times that angle, it's going to be the same value, right? Cosine of 2x is the same value, and so that's going to solve the equation. So, like, this is just a number. And we know that trig functions work for any unit of angle. It's not just defined like for degrees or something. So just note that everything we've learned about solving trig equations is applicable to any unit you want. All right, so let's get started. So a lot of times when it comes to these solving equations like trig equations like this, we're going to want to convert like cosine of 2x into like single angle trig functions, so that we could take all like cosine 2x, convert to single angle trig functions, and then we're left with an equation like we solved in the previous section that contains all single value trig functions. That's a default method you can go to solve equations like this. However, there are special cases where, like this, for example, where if all of the trig functions are the exact same trig function, then it doesn't matter if it's single angle or not. You could just make this is a linear equation in cosine 2x. Like we could say u is equal to cosine 2x, which is kind of unnecessary. This is so simple. And we get 2u is equal to root 3. You see? So there's no reason to convert this to something else. We can just say that, like, there's no reason to convert this to use the double angle formula here. We're just going to say cosine of 2x is equal to root 3 over 2. Okay. So now take the inverse cosine of both sides, and you get 2x is equal to okay, so now divide both sides by 2. Okay, so now just like we did with previous trig equations, we're going to interpret this, even though this is technically one value according to the inverse cosine function, we're going to interpret this in terms of all the possible values that when you take their cosine of those angles, you get root 3 over 2. So, okay, root 3 over 2 would be, let's see, a 30, 60, 90 triangle. So 1 root 3, 2. Okay, so let's see. Cosine of 30 is root 3 over 2. This is positive, so 30 degrees is 1. Now, where else is cosine positive? In quadrant 4. So what angle in quadrant 4 has reference angle 30 degrees? That's 330. Okay, and now I'm going to put dot, 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 because that includes any angle that's coterminal with these two angles. So if you take 30 or 330 and any angle that's coterminal with either of those two angles, and then divide that angle by 2, then that resulting value would satisfy this equation. Okay, so it's same idea. A lot of times we would see this sine 3 theta and think, well, let's break it down to get it in terms of just, single angle formulas, and then solve it, using the methods we learned to solve trig equations that contain all single angle trig functions. But that's not necessary here because we can just take the inverse sine of both sides and get 3 theta is equal to inverse sine of minus 1. So theta okay, now inverse sine of minus 1. So sine of what angle gives minus 1? That's the negative vertical. So that's between 0 and 360, that's 270. So theta is equal to 270, and that's actually the only angle between 0 and 360 that satisfies this. So coming out of the inverse sine function would be minus 90, but we're going to put 270, and then that's it. So any angle that's coterminal with 270, and then take that angle divided by 3, that's going to satisfy this equation. Okay, same idea here. We've got this lone trig function. So we don't need to consider breaking down this trig function. So, okay, we've got 3x is equal to inverse tangent. So x is equal to okay, now root 3 over 3, that's the same as 1 over root 3. So if we think about the 30, 60, 90 triangle, so 1. Okay, so tangent of 30 is 1 over root 3. So, okay, we've got 30 degrees. This is positive. Where else is tangent positive? It's positive in quadrant 3. So what angle has reference angle 30 in quadrant 3? That's 210. So there we go. So the answer is these two angles, any angle that's coterminal with these two angles, then divide the angle by 3, and that would satisfy this equation. Okay, divide both sides by root 2. Okay, now we can take the inverse cosine. So okay, now if we think about the 45, 45, 90 triangle, so cosine of 45 is 1 over root 2. We have minus 1 over root 2, so we think about, okay, well, let me divide both sides by 2. Okay, so theta, cosine is negative in the second and third quadrants. So, okay, reference angle 45 degrees in the second quadrant is 135 degrees. And then in the third quadrant, reference angle 45 is 225. So it's 135, 225, any angle coterminal with those, divide that by 2, and that would satisfy this equation. Okay, so here, again, do we need to use the half angle formulas to decompose these? No, we don't, because we can just use the exact same methods that we used in the previous section for just the regular trig equations with single angle formulas, because we can say we have the same trig expression throughout the entire equation. So if we say u is equal to sine of x divided by 2, we've got u is equal to root 2 minus u. So we have this is linear. Add u to both sides. 2u is equal to root 2. Divide both sides by 2. And there we go. But now u is equal to sine of x divided by 2. So, okay, so now we've got Okay, so x is equal to 2. All right, so now root 2 divided by 2, let's see. I don't think we have a triangle we can use for that. No, so okay, but that's fine. We're just going to plug this into you use the calculator. So inverse sine of root 2 divided by 2 is 40. Oh, so it is. Oh, that's 1 over root 2. Okay. So, okay, we could have used this. Yeah, 1 over root 2. So 45 degrees. This is positive. So where's sine positive? It's positive in the first and second quadrant. So we've got x is equal to 2 times 45 degrees, 135 degrees, and then any angle coterminal with either one of those two. So, all right, x, the solution to this equation is 2 times either 45 degrees, 135 degrees, or any angle coterminal with either of those two would solve this equation. Okay, now here we go. So now we can't just say that u is equal to sine of x or u is equal to sine of 2x. So how do we solve this? Well, the general strategy is going to be that you go to the angle that's not a normal single angle, sine of 1 times x, and just decompose it to get all single angle trig functions, and then go to then you need to solve a trig equation with all single angles like we did in the previous section. So, okay, sine of 2x is equal to 2 sine x cosine x. Okay, so we can say, change this to 2 sine x cosine x. And now it's like in the previous section. We solved this just like we would in the previous section. So, okay, we'll start by subtracting sine x from both sides. Now we factor out a sine x. Okay, so now sine x is equal to 0 solves this equation, and 2 cosine x minus 1 equals 0 solves this equation. So x is equal to inverse sine of 0, and x is equal to inverse cosine of 1/2. Okay, so where is sine of what angles equals 0? Well, that would be 0 degrees and 180 degrees, and any angle coterminal with those. What about 1/2? Well, or cosine of 1/2? Well, we think about the 30, 60, 90 triangle. If you got 1, root 3, and 2, so cosine 60 is 1 over 2. This is positive, so we've got 60 degrees. Now, where else is cosine positive? That's in the fourth quadrant. So what angle in the fourth quadrant has reference angle 60? That would be 300 degrees. So, okay. Either of these 4 angles or any angle coterminal with any of these 4 angles would solve this equation. Okay, you can see here we've got one type of trig function. It doesn't matter that it's a half angle. Who cares? It's the same type throughout the entire equation. So we just substitute a variable for that and turn it into an algebraic equation. If u is equal to secant squared x divided by 2, then this turns into 8u squared is equal to 4. That's a quadratic equation. So we can divide both sides by 4. That's okay. And we're left with 2u squared is equal to 1. Now divide both sides by 2. Yeah, okay, so we could do this and then take the square root of both sides. So you've got plus or minus 1 over root 2. So, okay, we've got that. Oh, I meant to put this is u is equal to secant x, not secant squared. And that's why we had u squared here. So, okay. So we've got that secant of x divided by 2 is equal to 1 over root 2, and or secant of x divided by 2 is minus 1 over root 2. All of that would solve this equation. So what we've got is x divided by 2 is equal to inverse secant 1 over root 2, or x divided by 2 is equal to inverse secant minus 1 over root 2. So, okay. What we can see is that, so 1 over root 2, that's going to be the 45, 45, 90 triangle. So 1, 1, root 2. And so secant is, or wait, no, there's going to be no solution here. Secant can never be, it could be root 2 over 1, but not 1 over root 2. So did we do this right? Let's see. U is equal to secant x divided by 2. So 8u squared is equal to 4. If you divide both sides by 8, you get u squared is equal to 1/2 plus or minus 1 over root 2. Secant x can, there's no angle where you take the secant of it and you get anything less than 1, and plus the magnitude of anything is less than 1, magnitude. And plus or minus 1 over root 2 is less than 1, the magnitude. So there's no solution to this. Okay, so let's see. We've got two separate trig functions, but can we convert this to where we have the same trig function throughout the entire equation? And yes, we can, because cosecant is the reciprocal of sine. So, and now we just say u is equal to theta, or no, u is equal to sine theta divided by 2. So we've got u is equal to, and this is like a rational equation, so u squared is equal to 1. So u is equal to plus or minus 1. So we've got sine of theta divided by 2 is equal to 1, or sine of theta divided by 2 is equal to minus 1. So theta divided by 2 is equal to inverse sine of 1, or theta divided by 2 is equal to inverse sine of minus 1. So, okay, inverse sine of 1 and minus 1. I mean, I can write this out. So theta is going to be 2 times inverse sine of 1 or inverse sine of minus 1. So what is inverse sine of 1 and minus 1? That's the positive vertical, and the negative vertical is the angles where you take the sign and you get 1 or minus 1. So what we're going to have is, we'll have 90 degrees, 270 degrees, ... meaning any angle coterminal with those angles. So if you take 90 degrees, 270 degrees, or any angle coterminal, but then you multiply that by 2, then what you get is that would satisfy this equation. Okay, we've got a mixed, we can't just make a substitution and convert this into something algebraic. So let's convert cosine 2x to just single angles using the double angle formula for cosine. So cosine 2x is equal to, and we want to make it in terms of just cosine, so 2 cosine squared minus 1. So, okay, 2 cosine squared of x minus 1 plus cosine x is equal to 0. So now we've got all cosine x's. So we can say u is equal to cosine x. So 2u squared minus 1 plus u is equal to 0. Now it's just a quadratic formula or equation here to solve. So, okay, 2u squared plus u minus 1 is equal to 0. So can we factor this? We've got 2 times minus 1 is minus 2. Yeah, we should be able to say 2u squared plus 2u minus 1 is equal to 0. So factor out a 2u over here. We're doing grouping. If you don't know what I'm doing here, this is all, we learned this in the algebra playlist. Plus 1, then factor a minus 1 here. So now we can factor a u plus 1. Okay, so we've got u is equal to 1/2 and u is equal to minus 1. But u is equal to cosine x. So, okay, cosine x is equal to 1/2, or cosine x is equal to minus 1. So x is equal to inverse cosine of 1/2, or x is equal to inverse cosine of minus 1. Okay, so let's see. We've got the 30, 60, 90 triangle. 1 root 3, 2. So cosine of 60 is 1/2. So, okay, we've got 60, and then cosine is positive in quadrant 4. What angle in quadrant 4 has reference angle 60? Okay. Now, inverse cosine minus 1 is, so where is cosine minus 1? That's at 180 degrees. So 180, and that's it. That's the only angle between 0 and 360 where cosine is, if that angle is -1. So, okay, these three angles, or any angle coterminal with one of those three angles, satisfies this equation. Okay, here, same idea as the previous problem, but we can use the other double angle formula for cosine 2 theta. Cosine 2 theta is 1 minus 2 sine squared theta. Okay, so 1 minus 2 sine squared theta. So now we've got all sine thetas. Okay, so say u is equal to sine theta, so 2u and then 1 minus 2u squared. Okay, 2 minus 4u squared is equal to 2u. So we've got, let's see, 4u squared plus 2u minus 2 is equal to 0. Divide this whole equation by 2, so 2u squared plus u minus 1 is equal to 0. So, okay, u is equal to minus 1 plus or minus b squared minus 4 times 2 times minus 1 all over 2 times 2. So 1 plus 8. So that's going to be square root of 9. So we could do minus 1 plus or minus 3 over 4. So u is equal to, yeah, that's it. So, okay, we've got sine theta is equal to minus 1. Well, no, we can simplify this. So, yeah, u is equal to minus 1 plus 3 is 2. 2 divided by 4 is 1/2. Minus 1 minus 3 is minus 4. Minus 4 divided by 4 is minus 1. So, we've got sine theta is equal to 1/2, or sine theta is equal to minus 1. So or theta. Okay, so 1 over 2, that would be, so 30, 60, 90 triangle. Got 1 root 3, 2. So sine of 30 is 1 over 2. So theta is equal to 30 degrees. Sine is positive in quadrant 2 as well. So reference angle 30 degrees would be 150 degrees. Or theta, so sine is -1 at 270. Sine of 270 is -1, and that's it. So these three angles, any angle coterminal with those three angles, all that would satisfy this equation. Okay, once again, we can transform that cosine 2x into, what is it, 1 minus 2 sine squared of x? Yes. So 1 minus sine of x, and you got 1 minus 2 sine squared x, and there we go. So now we can say u is equal to sine x, so 1 minus u is equal to 1 minus 2u squared. So we've got, let's see, add 2u squared to both sides, and then subtract 1 from both sides, and we're left with this. Factor out a u. So we've got u is equal to 0, u is equal to 1/2. Okay, so sine of x is equal to 0, or sine of x is equal to 1/2. So x is equal to inverse sine of 0, or x is equal to inverse sine of 1/2. So if we think about the 30, 60, 90 triangle, we've got, okay, so sine of 30 is 1/2. This is positive, so 30 degrees. Sine is positive in quadrant 2 as well, so 150 degrees. That's the same reference angle. Now sine is 0, or sine of 0 degrees is 0, and sine of 180 degrees is 0. And okay, now if I'm going pretty fast here, if you think I'm going too fast, then go watch some of the other videos leading up to this, where I talk about this, and I go a lot slower and explain what I'm doing. We go through the textbook, so we're coming to the end here, and so I'm going through these pretty quick just to go through the mechanics. Okay, so any of these 4 angles and any angle coterminal with these 4 angles would satisfy this equation. Okay, here, secant and cosecant are not reciprocals. So we think about, maybe there's a trig identity here with cosecant squared, Pythagorean identity. We have cosecant is related to cotangent, so that's not going to help. At least nothing I can see right at first. Oh, but yeah, we've got a half angle for cosecant. So what's the half angle formula for cosecant? So half angle formulas, let's see. Okay, but we know there's other half angle formulas, so let's come to the textbook and grab the half angle formulas for the textbook. Okay, so if we can look at this way. Remember how there's no cosecant here for the half angle formulas, but that's fine, because what's the reciprocal of cosecant? That's sine. So we know that cosecant of any angle, and so x divided by 2, that's fine, whatever. Cosecant of x divided by 2 is going to be written, you can write that as 1 over sine of x divided by 2. Okay, well, there's sine of x divided by 2. So that's 1 minus cosine x over 2. Okay, like that. There we go. But now we can square both sides here and get this. The plus or minus goes away, and we're left with this. And so like that. So okay, that's cosecant squared of x divided by 2. So let's substitute this in. We've got okay, so 6 over, now what is secant? That's 1 over cosine. And there we go. So now we can say that u is cosine x. So now we've got this rational equation here. So 2 times 1 minus u. Okay. So 2 minus 2u is equal to 6u. So 8u is equal to 2. U is equal to 1/4. And is that, we need to check to see if that's a domain issue? No. So we've got u is equal to cosine x. So cosine x is equal to 1/4. So x is equal to inverse cosine of 1/4. So, okay. Let's see. We've got so 75.5, and we have positive 1/4, so that's going to be one angle, 75.5. But cosine is positive in quadrant 4 as well, so what angle in quadrant 4 has this as a reference angle? Take 360, so 284.5. Okay, so these two angles, or any angle coterminal with these two angles, satisfies this equation. Okay, do we need to go get the double angle formulas for sine here to decompose this? No, because we've got the same trig function throughout the entire equation. We just make a substitution for a variable for that and turn it into the whatever algebraic equation comes out of it. So 2 minus u is equal to 4u. Add u to both sides. 5u is equal to 2. So u is equal to 2/5. So okay. So we got 2 theta is equal to, so theta is equal to, okay, so theta is, okay, so inverse sine 2/5, it's 23.6 degrees. So 23.6 degrees, and sine is also positive in quadrant 2, so 180 minus this 156.4. Okay, so these two angles, any angle coterminal with those two angles, then divide that by 2, and that would satisfy this equation. Okay, same idea. We have the same trig function throughout this entire equation. So make a substitution for a variable. We have 2u squared is equal to 1 minus u, quadratic equation. So add u to both sides. Okay, now let's see. We've got 2u squared plus 2u minus u. Okay, so now so u is equal to 1/2, u is equal to -1. So, okay, we've got cosine of 2 theta is equal to 1/2, or cosine of 2 theta is equal to -1. So 2 theta is equal to inverse cosine of 1/2, or 2 theta is equal to inverse cosine -1. So, okay, with the 1/2, we've got a 30, 60, so 1 root 3, 2. So, okay, theta is equal to, we've got, so theta is equal to, cosine of 60 is 1/2, so 60 degrees. Now, cosine is positive in quadrant 4, so 60-degree reference angle in quadrant 4 is 300. Okay, or theta is, so cosine is -1 at 180 degrees, and that's the only angle between 0 and 360. So, okay, take 60, take 300, take 180, or any angle coterminal with those angles, then divide it by 2, and any of those would satisfy this equation.